So good morning to all. Welcome you all on behalf of E2 Academy. Welcome you all for the free online class course on problem solving techniques in analysis. For these 2 days, we are going to discuss some previous year questions from GATE and then CSER, only real and complex analysis question papers. So if you have any doubt, you can ask in the chat box. And one more thing, the recorded video is available in the same website up to 7 days. You can utilize it anytime. Okay, so now I share my screen. You can see my entire screen. Please wait. Okay, now I think my screen is sharing. Yeah, it's shared. Okay. Okay, good. Now we discuss one by one problem. Now look at the first problem. Now look at this first problem. This is sequence of functions. Let fn of x equal to x power 1 by n for all x in closed interval 0, 1. Then which of the following is true? Okay. Now look, we have to find the point-wise limit for this sequence of functions. So how to find the point-wise limit? We got to substitute for each values of x. We got to find the limit of this sequence. Okay. Now we now consider the first problem. So what is our sequence of function? Fn of x equal to x power 1 by n, where x varies from closed interval 0, 1. Now substitute x equal to 0. So what will get? Fn of 0. So Fn of 0 is a sequence. So what is the sequence? This is 0 power 1 by n. So 0 power 1 by n is nothing but 0. Therefore, this is constant sequence. Therefore, this converges to 0 as n goes to infinity. Okay. Now consider x equal to 1. So that is Fn of 1. So substitute x equal to 1, 1 power 1 by n. This is nothing but 1. Again, this is a constant sequence. Therefore, this converges 0 as n goes to infinity. Suppose you assume that x lies between 0 and 1. Then what is Fn of x? So this is nothing but x power 1 by n. And we know that this is converges to 1. Okay, because we know that for any a positive, a power 1 by n converges to 1. Right? Therefore, this is converges to 1 as n goes to infinity. Therefore, we know all the values of x, we know the limit. Therefore, you can write the sequence Fn of x converges to maybe we call some f of x. So this f of x is actually nothing but for 0, for x equal to 0, the value is 0. For all other values of x, we get 1. Okay. Point-wise limit for this sequence of functions. Okay. Okay. Now, what do you look at the options? Okay, look at the first options. A limit n goes to infinity, Fn of x exists for all x. Yeah, it is true. Because for each values of x, the sequence converges. Fn of x converges. Therefore, this limit is exists. Therefore, the first one is correct option. But look at the second one. The limit Fn of x defines a continuous function. But look at the function f of x. F of x is nothing but the limit of the sequence. But this is not a continuous function. This is not continuous at x equal to 0. Because if you draw the graph of the function f of x, so for 0, we get 0. But in between 0 and 1, it's take 1. Okay. Therefore, the function looks like this one. But except this point. Therefore, this function is not continuous at x equal to 0. Therefore, the second option says the limit, actually we can rewrite some other form, limit n goes to infinity, Fn of x is nothing but f of x, where f of x is nothing but this one. We know that f of x is not continuous. Okay. Look at the second option, they say it's a continuous function, it's not continuous function. Now, third option is Fn of x converges uniformly. So we know the result. Suppose the sequence of function converges to f uniformly, and each Fn is converges, then the limit should be continuous. Clearly, f of x equal to x power n, this is a continuous function. Okay, so Fn of x equal to x power 1 by n, this is a continuous function for each n. Okay, therefore, suppose Fn of x converges to f of x uniformly, the theorem says that limit should be continuous. But in this case, the limit is not continuous. Therefore, Fn of x does not converges to uniformly, but is converges to point-wise to f of x, but does not converges to uniformly to f of x. If it is uniformly, then f should be continuous because each f1 is continuous. If it is uniformly, then the limit also continuous. But in this case, limit is not continuous. Therefore, third option is false. And look at the last option. They say the limit is always 0. That is not true because we get the limit is 0 only for x equal to 0. And then for all other values of x, we get 1. Therefore, the last option is false. Okay. Now look at the second problem. Therefore, the first one is the correct one. So the limit exists for all x. Now look at the second one. Suppose I equal to 2.8, that is 1, 2, otherwise they write union singleton 1, union singleton 2. It's nothing but just 1, 2, 2.8. And then they define a distance function, that is pi of x equal to distance of x, I. Okay, where x varies over a real number, but I is nothing but just 2.8. It's nothing but infimum of modulus of x minus y, such that y in I. Okay. Now we have to discuss about the continuous of this function. Okay. Now, first you got to write the definitions properly. So the given I equal to 2.8, 1, 2. And then define the phi is a function from R to R. Is defined to be pi of any real number x, defined to be distance of x, I. So what is the definition of this? It's nothing but infimum of here for each x is fixed, okay, y is varying. That's that y belongs to I. Since I contains only 2 elements, therefore you can write infimum of modulus of x minus 1, modulus of x minus 2. So infimum of these 2 elements is nothing but pi of x. Now we know the graph for modulus of x. So therefore we have a modulus of x minus 1. So first you draw the graph for modulus of x. So this is like this one. So this is mod x graph. But we need a mod x minus 1 graph and mod x minus 2 graph. And then from these 2 graphs, we got to take the minimum. So, 0. If substitute x equal to 1, we get 0, right? Or if substitute x equal to 0, sorry, x equal to 1, we get 0. Therefore, this is 1 and this is 2. For x equal to 1, this is 0. Therefore, the graph cross this point and then look like this. So this is nothing but just a translation of this mod x is nothing but mod x minus 1. The translation point is 1 unit. So similarly for mod x minus 2 graph is look like this one. Okay, so this is mod x minus 2 graph and this is mod x minus 1 graph. So the 2 graphs meet at the point here. Actually, this point is nothing but midpoint of 2 and 3. So what is the midpoint? 3 by 2. Okay. So now what is the minimum value? So minimum of the function or infimum or minimum. So infimum of the graph is nothing but just the lower curve. So I draw here. So the lower graph look like this one. Okay. So this is 1 and 2. So this is the graph for infimum of modulus of x minus 1, modulus of x minus 2. So this is the infimum. Okay. Now it is continuous everywhere because the look at the function. This function is continuous everywhere. There is no problem. But there is some sharp corner in 3 points. So in these points, the function is not differentiable because whenever we have a sharp corner, the function is not differentiable at the points. Okay. So therefore, we have 3 points, that is 1, and the midpoint, that is 3 by 2. And then 2. So it is continuous everywhere, but not differentiable at this point. Okay, because we have a 3 corner point, 1, 3 by 2, and 2. Now look at the options. Look at the last option. So pi is continuous or not? Because look at the function graph, the function is always continuous because there is no gap. So it's always continuous, but it's not differentiable only at 1 and the midpoint 3 by 2 and 2. So this is the correct answer. All other options are wrong because look at the first option. This is a discontinuous somewhere. No, look at the graph. It's not discontinuous. It's always continuous. Okay. So this is our function pi of x. Okay. This is the graph for pi of x. So it's always continuous everywhere. Therefore, first option false. Look at the second option is A is continuous but not differentiable only at x equal to 1. But we have a sharp corner for x equal to 2 as well as x equal to 3 by 2. Therefore, whenever we have a sharp corner, that function is not differentiable at this point. So therefore, the second one is false. Similarly, third one says is differentiable only at x equal to 1 and x equal to 2. Therefore, that is not true because we have 3 corner points. Okay, one at the point 1 x equal to 1 and x equal to 3 by 2 and 2. Therefore, the last one is the correct answer. Okay. Now, look at the next problem. Let x comma d be a metric spaces. Metric space and let A is a subset of x. For each x in x, we define again the distance function d of x comma a is nothing but infimum of distance between x comma a, where a in a. Okay. So suppose distance between x comma a equals 0 for all x, then which of the following must be true? Okay. So we have a condition for each x, the distance is 0. Now, so what are you meaning with so from that what we concluded? So we given that x comma d is a metric space, okay, and a is a subset of x. Okay. Now they given that distance between x comma a is always 0 for all x. It is hypothesis. From that, what we conclude that about a must be true. Okay. Now we can say a is a dense set. What do you mean by a is dense? So we say a is a dense set in x if the closure equal to x. If a closure equal to x, then we say a is dense in x. Okay. So if this is happen for all x, then we are going to show a should be a dense set. So that means what we can show a bar equal to a. Since already we know that a is a subset of x, therefore a closure is a subset of x. Now we have to show the reverse implication, that is x is subset of a closure. We have to show that x is a subset of a closure. Therefore, we take arbitrary x. We have to show that x belongs to a closure. That means what? X is a limit point of a. That means what? We have to find a sequence in a which is converges to x. Okay. So we take arbitrary element x in x. So what is our aim? So aim is we have to show that x belongs to a closure. Okay. So that is we have to show x is a limit point of a. That is there is a sequence an in a such that an converges to that x. So that is our claim. Now we know that distance between a comma x comma a equal to 0 for all x. So that is for in particular for this maybe we take y for simplicity, we take y. Okay. So now we know that distance between this y comma a is always 0. Okay, because this is true for all x. In particular, take x equal to a. Therefore, distance between y comma a equal to 0. So what is the definition of distance between y comma a? Is nothing but infimum of distance between y comma small a such that a in b. So this infimum is 0. So we know that infimum and supremum is always a limit point of a set. Okay, that means what? Suppose infimum of a set some s equal to L means what? L is a limit point of s. That means what? There is a sequence some Sn in S such that this Sn converges to L. Similarly, suppose supremum of some set s equal to some k. Again, k is a limit point of the set s. So therefore, we have to should know that infimum and supremum of a set is always a limit point. So limit point means what? We have to find a sequence in the set converges to that point. So therefore, here infimum of this set. What is our set? Distance between y comma a such that a in a. So infimum of this set equal to 0. That means what? 0 is a limit point of this set. That means what? There is a sequence in this set. So the sequence here a only varying, right? Therefore, the sequence look like distance between y is fixed. So only we have to find the in the second coordinate only we have sequence. So there is a sequence in the set. Maybe better we call some other notation for this set. Otherwise, keep the same notation. So there is a sequence in the set such that the sequence d of y comma an converges to that point 0. That means what? So actually this distance between y and an is very close. That means what? That is this is as n goes to infinity. That means what? An converges to y. So therefore, we have find a sequence in A because an is a sequence in A. So all the ans belongs to this A. Therefore, we have to find a sequence in A such that this converges to y. But we take y is an arbitrary element in X. Therefore, this X is a subset of A closure because every point of X is a limit point of A. Therefore, X is a subset of A closure. We already know the one containment, that is A closure is a subset of X. Now combine these two, we get X equal to A closure. That means what? X, A is a dense set in X. Therefore, it must be true that A is dense in X. Okay. You have to eliminate all the other conditions. Okay. Must be true is A should be dense. Now, next problem. Now look at this sequence of functions. So f1 of x equal to 1 minus nx for x lies between this interval 0 to 1 by n. For other interval, remaining interval, we have 0. Now we have to discuss about the limit of this sequence of functions. Okay. Now, we write the function f(n) of x equal to 1 minus nx, where x lies between 0, 1 by n, and 0, x belongs to 1 by n, 1. Okay. Now, you have to find the point-wise. First, you have to find the point-wise limit of this sequence of functions. Now, substitute x equal to 0. So, what is the limit of the sequence when x equal to 0? That is, what is f(n) of 0? So, 0 lies between this interval, this 0 and 1 by n. Therefore, x equal to 0 means we get just to 1. Okay. Therefore, this is a constant sequence. This converges to 1 as n goes to infinity. Okay. Now, if you take other values, okay, suppose take x equal to 1. So, x equal to 1, therefore, lies in this interval. So, therefore, what is the f(1) of 1? f(1) of 1. Since 1 lies between lies in this interval, therefore the corresponding f(1) of value is 0. Therefore, this is 0. This always converges 0 because again is a constant sequence. Therefore, as n goes to infinity, f(n) of 1 also converges 0. Now we got to find the other values of x. That is 0 strictly less than x, strictly less than 1. So what is the value of f(n) of x? Okay. So actually, this is actually is a eventually 0 sequence. Why? So specifically, if you take a simple value, okay, suppose take x equal to 1 by 2. Okay. Now you have to find the sequence f(n) of 1 by 2. So this is actually nothing but now substitute x equal to 1, 2, and so on. So what is that? f(1) of 1 by 2, f(2) of 1 by 2, f(3) of 1 by 2, and so on. Maybe write f(4) of 1 by 2. So actually, we have to find the sequence is facility. So what is f(1) of 1 by 2? Since 1 by 2 lies in the interval 0, 1 by 2. Okay. So okay, first look at this one. So here in this case, what is our n? N equal to 1. So here n equal to 2. So here n equal to 3. This is n equal to 4. Now if consider n equal to 1 and then this point. So if n equal to 1 means 1 by 2 lies in the interval 0, 1 because we take n equal to 1, right? Therefore, look at this function. If substitute n equal to 1, we get 0 to 1. Okay. If substitute n equal to 1, we get 0 to 1. So for 0 to 1, if substitute n equal to 1, we get what is the corresponding value? 1 minus nx, 1 minus n is 1, x is 1 by 2. Okay, so this value is actually nothing but 1 by 2. Therefore, f(1) of 1 by 2 value is 1 by 2. Now, what is f(2) of 1 by 2? That is here n equal to 2. Therefore, look, consider this interval. So again 1 by 2 is in this interval. So therefore 1 minus n is 2, x is 1 by 2. Therefore 1 by 2, 1 by 2 cancel, 2 and 1 by 2 cancel, we get 1 minus 1 is 0. Again, otherwise you can look at this interval 1 by 2, comma 1. X also lies in this interval. For f lies in the interval, the value is 0. Anyway, if x lies in this interval or this interval, the value is always 0. Therefore, this value is 1 by 2, the second value is 0. Now we have to find the third value. That is, in this case, n equal to 3. Therefore, we have to consider the interval 0, 1 by 3, and then 1 by 3, 0, 1 by 3, 1. Now we have to check 1 by 2 lies which interval. So we know that 1 by 2 is bigger than 1 by 3. Okay. Therefore, 1 by 2 should be lies in this second interval. Therefore, for second interval, the value is 0. The function for the second interval, the function value is always 0. Therefore, f3 of 1 by 2 is 0. Similarly, you can find f4 of 1 by 2 value is 0 and so on. Everything is 0. Therefore, we get the sequence for x equal to 1 by 2. We get the sequence 1 by 2, 0, 0, 0, 0, 0, and so on. So therefore, this is eventually 0 sequence. So certain stage, after the stage, everything is 0. Here we get a first stage. For x equal to 1 by 2, we get the first stage itself. We get a eventually 0 sequence. Therefore, this converges to 0. If you take any other value, so after certain stage, we get everything is 0. Therefore, this converges to 0. Therefore, the pointwise limit is for all other values of this f1 of x converges to 0 as n goes to infinity. So therefore, we write in a simple form. So we erase everything. So for all values of x, other values of x, the sequence is actually nothing but eventually 0 sequence. That means what? So after certain stage, all the sequence terms should be 0. Now, write the limit of pointwise limit of this sequence of function. This converges to f of x is nothing but if x equal to 1, we get 1. For all values of this, we get 0. Okay. Therefore, the limit is, this is actually we call f of x. Clearly, this f of x again is not a continuous function. Okay. But each, now look at the function options. Look at the first option. So the limit n goes to infinity f1 of x defines a continuous function. Clearly, this is not a continuous function because this f of x is nothing but limit of this f1 of x. Limit n goes to infinity f1 of x. They say the f of x is continuous function, but clearly this is not a continuous function, it's a discontinuous function. The first one is false. Again, f1 of x converges uniformly on this interval. Again, this is not uniformly. Why? Because each f1 is continuous function. Why it is continuous function? Again, use the, since for this interval, this is straight line. Okay, it's a linear equation, therefore it's continuous. For this interval, this is 0 function, constant function, therefore continuous. By pasting lemma, this is continuous function, this is continuous function. Now for the endpoints, so what is the endpoints? 1 by n. For 1 by n, both the functions they have same value. If substitute x equal to 1 by n here, 1 by n and n cancel, we get 0. 1 minus 1, 0. This is always 0. Therefore, for the endpoints 1 by n, two functions are agree on the endpoint. Therefore, by pasting lemma or boolean lemma, we get a continuous function. Therefore, each f1 of x is a continuous function. Suppose this f1 of x converges to uniformly continuous for the limit f of x, then f of x should be continuous. So, but here we have f of x is a, each f1 is continuous, but f of x not continuous. F of x does not converges uniformly to the function f of x. Therefore, second option is false. Look at the third option again. They say the limit is always 0, but we get the limit is 1 for the value x equal to 1. Therefore, again, third one is false. Now look at the last one. Limit n goes infinity f1 of exists for all x. Yeah, it is exists for each values of x. The values exist. That means what? For each values of x, that f1 of x converges. So therefore, limit is exist. Therefore, last one is the correct one. Okay. Okay. So for any doubt, no. Okay. Now look at the next problem. Again, look at this same problem we discussed in the second problem, right? So, but here they given that I is a interval. But in the previous problem, we discussed I contains only two elements, that is 1 and 2. But here we consider the interval. Now again, the same function, the distance function. So we have to discuss about continuous and the differentiability of this function pi. Okay. So same thing, for once you draw the graph, you get the answer. Now, fifth problem, they say take I equal to close interval 0, 1. Again, phi is a function from R to R, defined by phi of x equal to distance of x, identity. That is, interval I. So this is nothing but infimum of, by the definition, this modulus of, because we have the real case, therefore you can write the usual metric, x minus y, such that y in I. Okay. So now draw the graph for this one. So here y varies in close interval 0, 1. Therefore it has uncountably set. Therefore there are infinitely uncountably many points there. Therefore, if you draw the graph of this, with this 0 and this 1, if you take a y equal to 0, we get mod x, right? Therefore draw the graph mod x graph. So this is mod x graph. So if you take next point, if you take 0 point, maybe better 0.1. If you take y equal to 0.1, we get x minus 0.1. That means for just a translation of this mod x graph. Therefore, maybe this is 0.1. So consider this is 0.1, but this is not look like this one. Maybe this one. So this is the graph of this next point. So again, if you take the next point, we have this one. Okay. Therefore, for each point in the close interval 0, 1, we have a mod x minus that point. Okay. Therefore, finally, if you take y equal to 1, the end point. So for the end points, we get a graph look like this one. Okay. Therefore, look, everything look like this one. The graph look like this one. Okay. But we are going to take the infimum. So therefore, if you take the infimum, what is the minimum value of this graph? So directly write draw the graph. So this is a minimum because there is no graph after this. There is no graph here. Therefore, the minimum one is we get the mod x equal to 0. We get the one side for one side graph. So this is 0. We get the minimum this side, and then this side also we get 1. So therefore, we get a graph look like okay. This is lies in the x-axis. Okay. So sorry. So should be in the x-axis. Okay, this is a graph. So this is a minimum of all these graphs. Now we have only two corner points. Only for x equal to 0 and x equal to 1. Only we have two corner points. Because if we take the minimum of the middle graph, we get the same thing. Because every graph meet the x-axis, therefore the minimum should be x-axis. Therefore, this is a graph of, so it's always the minimum always in the x-axis for all other points. For x equal to 1, we get this graph. Okay, so this is a graph of the pi. Therefore, in this clearly this is continuous function because there is no discontinuous, and we have two corner points. The two corner edges. Therefore, this pi is not differentiable at x equal to 0 and x equal to 1. So only these 2 points, the function is not continuous, sorry, not differentiable, but all other points is it is differentiable and continuous everywhere. Now look at the last option. Pi is continuous on R, but not continuously differentiable exactly at x equal to 0 and x equal to 1. So only these 2 points, the function is not differentiable. Okay. But look at the third option, is differentiable on R? No, because we have some sharp corner, therefore this is not differentiable on R. Again, look at this second option says not continuous, not differentiable only at x equal to 0. That is not true because we have a sharp corner at x equal to 1 also. Therefore, that is not true. And first one is discontinuous. Again, this is not, it's not discontinuous, continuous everywhere, but not differentiable at 2 points. Okay. So that is a answer. Therefore, the last one is a correct answer. Now look at this complex analysis problem. Consider the function f of z equal to x square plus I y square and g of z equal to x square plus y square plus I times xy. So at the point z equal to 0, we have to say the function is analytic or not at this point. So we know that what do you mean by analytic at a point? suppose we say a function f is analytic at a point z naught, then the function is differentiable around this neighborhood z naught. Okay, so that is the definition. But we are going to use the theorem. Suppose it is analytic, then it's always satisfies CR equation, or is satisfy the, suppose it's analytic, it's always satisfy the real part and the imaginary part are always satisfy the harmonic function. So to satisfy the Laplace equation. So what is the Laplace equation here? So uxx. So look at the first function. So if you consider f of z equal to x square plus I times y square. Okay. Now therefore you suppose analytic means u, what is the real part, x square. We take v is y square. Therefore u and v satisfy this Laplace equation. uxx plus uyy 0 and vxx plus vyy should be 0 if it is analytic. Suppose f is analytic, then these two functions satisfy the Laplace equation at the point z equal to 0. So first find what is ux. So ux is nothing but 2x. So uxx is 2. And what is uy? Since y is independent of y, therefore 0, and uyy is also 0. Therefore uxx plus uyy is, we get just 2. So 2 is not equal to 0. Therefore, is not satisfy the Laplace equation. Suppose if f is analytic, then it's, the real part and then imaginary part should satisfy the Laplace equation. But here the real part does not satisfy the Laplace equation. Similarly, you can check that the imaginary part y square is also not satisfied the Laplace equation. Therefore, this function is, because after this there is no x and y. Okay, if it is x1 means we got to substitute x equal to y, because we have to check for the point z equal to 0. So after that we have to substitute x equal to 0, y equal to 0. But here we didn't get any. This is not a function of x1. It is not a analytic function. Similarly, look at the second function g of z equal to x square plus y square plus I times xy. So again, what is our u? U is nothing but x square plus y square. Now we have to find the uxx. So ux is nothing but again 2. And what is uyy? Again, this is also 2. Therefore, uxx plus uyy is 2 plus 2 is 4. Again, this is not equal to 0. Therefore, this cannot be an analytic function. If it is analytic, then it's always the real part and the imaginary part should satisfy the Laplace equation, but it's not set. Therefore, neither f nor g is analytic. Okay. Suppose analytic means, suppose you are assuming analytic, then it's always the real part and the imaginary part satisfy the Laplace equation, but it's not, does not satisfy the Laplace equation at the point z equal to 0. Therefore, it's not even these two functions not analytic at even any point. Not only for z equal to 0, it is not analytic at any point. Now look at the next problem. So suppose this sum value is they given that pi square is 6, then what is the value of this summation? Okay. Actually, just a simple calculation. You have to rewrite the given summation. So they given that summation n equal to 1 to infinity 1 by n square. This is equal to pi square by 6. Now the question is, what is the summation 1 by 2n plus 1 whole square, where n equal to, I think, 1 to infinity. Okay. Now, what is the value of this summation? So first, what is the meaning of the? So just to explain this is nothing but 1 by 1 square, that is 1 plus 1 by 2 square plus 1 by 3 square and so on. So this is nothing but pi square by 6. Now just to expand this summation. Now substitute x equal to 1, sorry, n equal to 1, we get a n equal to 1 means 2, 1, 3. So 1 by 3 square. And substitute n equal to 2, we get 5 square. And then substitute n equal to 3, we get 7 square. Therefore, we get only the square of the odd numbers. Okay. So this is the expansion of this summation. Now you got to add and subtract the even powers also. So therefore, we start from this 1 by 3 square plus 1 by 5 square plus 1 by 7 square and so on. So this is the original summation value expansion. Now we can add 1 by 2 square. Okay, so you can add 1 also. Because we are going to use the given hypothesis, right? Therefore 1 plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square and so on. So now you can add 1 by 2 square, 1 by 4 square, 1 by 6 square. Therefore, you got to subtract all these things. Okay. So what we got to subtract now? Take the minus outside for all the subtraction. Therefore, you get 1 plus 1 by 2 square plus 1 by 4 square plus 1 by 6 square and so on. Okay. Now, so what do you get? Now this is nothing but pi square by 6 because the given this hypothesis 1 square plus 2 square plus 3 square is nothing but pi square by 6. Now minus, so this is nothing but only we have a okay, better we write expand this. So better we take 1 by 2 square outside. So minus 1 just to multiply minus inside, therefore minus in this minus 1 by 2 square, minus 1 by 4 square, minus 1 by 6 square and so on, minus 1 by 8 square, everything is a even power. Okay, and so on. So now it's nothing but pi square by 6 minus 1. Now from all these other terms you take a 1 by 2 square is outside. Okay, therefore minus 1 by 2 square you can take outside. Therefore this is we get 1 plus, so 1 by 4 actually nothing but 2 into 2. So if we take 2 square outside, therefore this is 1 by 2 square plus, so actually 1 by 6 is nothing but 1 by 6 square is nothing but 1 by 2 square into 3 square. Therefore you can take outside the 1 by 2 square, therefore we are remaining 1 by 3 square. Okay, now 1 by 8 square is nothing but 8 can be written as 4 into 2. Okay, or 2 into 4 square. Now you can take 2 square outside, therefore we have 4 square. So on so on. So again this value is nothing but pi square by 6. Therefore we have pi square by 6 minus 1 minus 1 by 4 into this value is pi square by 6. Okay. Now this is you can take pi square by 6 outside. 1 minus 1 by 4 and then remaining minus 1. So 1 minus 1 by 4 is nothing but 3 by 4. Therefore 3 by 4 times pi square by 6. So 1. Now you can cancel this 3 and this 6 2. 2 into 4 is 8. Therefore pi square by 8 minus 1. So this is the answer. The sum of value of the summation pi square by 8 minus 1. Very simple things. Now next problem. So which of the following a real valued function on the open interval 0, 1 is uniformly continuous? So we know we have some theorem. Suppose the function is uniformly continuous, we take Cauchy sequence to Cauchy sequence. Okay. Suppose the function f of x equal to 1 by x is uniformly continuous on this interval. Okay. Suppose so our interval is open interval 0, 1. So first option is we have to check f of x equal to 1 by x is uniformly continuous or not. Suppose it is uniformly continuous, take the Cauchy sequence xn equal to 1 by n plus 1. This is sequence in open interval 0, 1. Okay, this is a Cauchy sequence. Why it is a Cauchy sequence? Because it's converges sequence in R, therefore it's a Cauchy sequence. Now what is f of 1 by n plus 1? Is nothing but, now substitute x by, replace x by 1 plus x1, therefore we get a n plus 1. But n plus 1 is not a convergent sequence, therefore it's not a Cauchy sequence. It's not Cauchy. But xn is Cauchy, but f of xn is not Cauchy. But we assume that suppose it's uniformly continuous, then Cauchy sequence takes to Cauchy sequence. But this does not take Cauchy sequence to Cauchy sequence, therefore this is not a uniformly continuous. It's not uniformly continuous. Okay. So again, look at the second one. Same thing. Suppose f of x equal to sin 1 by x. So look at the same example. Take the xn equal to 1 by n plus 1. So f of 1 by n plus 1 is nothing but sin of 1 by n plus 1, that is sin of n plus 1. So again we know that sin n is a divergent sequence, therefore it's not a convergence. We know that for the real sequence, Cauchy sequence, if only if convergent sequence. Anyway, we know that the sin n plus 1 is not convergent sequence, therefore it's not Cauchy sequence. F of x equal to sin of 1 by x is not uniformly continuous. Because because it does not take partial sequence to partial sequence. And similarly, you can check third one, f of x equal to cos x by x. Again, you can show that. Otherwise, one more theorem is there. Suppose a function is continuous on the closed interval 0, 1, then it is uniformly continuous. Okay? But the function is defined here, open interval 0, 1 to r. Okay? Suppose if you define new function g defined on the closed interval 0, 1. So that means what? The function f can be extended to the closed interval 0, 1. It is possible that. So it's defined. Actually, g is actually nothing but just the extension of f. Okay, that means you have to define the function at the endpoints, and the function should be continuous. Now, look at the last example. We given that f of x equal to sin x by x. But this function is defined only in the open interval 0, 1. If substitute x equal to 1, then this function is defined. That is not. Now, substitute x equal to 1, 0, that is not defined. Okay. Therefore, the problem is at the point x equal to 0. So, if it is possible to define some value for the value x equal to 0, then this function is uniformly continuous. That means you have to check limit x goes to 0, f of x exists or not. So, we know that limit x goes to 0, sin x by x. We know that by using the L'Hospital rule, sin 0, 0, 0 by 0 format. Therefore, you have to differentiate numerator and denominator. Sin x differentiation is cos x. And then this is 1. Now substitute x equal to 0, cos 0 is 1. Okay. Therefore, at the endpoints, at the two endpoints 0 and 1, the function values exist. Therefore, we can extend the function to the endpoints also. Again, it is continuous. Therefore, it is uniformly continuous. Continuous function on the closed interval 0, 1. Therefore, it's uniformly continuous. But look at the third option. We cannot get the value for the endpoints. Because the limit x goes to 0, cos x by x, we didn't get any particular value. We cannot use the L'Hospital rule because sin 0, cos 0 is 0. So we get actually, 1 by 0. So that is infinity. That is 1 by 0 is not a this form. So actually, this is not a uniformly continuous. Otherwise, you can use the same sequence definition. Okay. So therefore, the uniformly continuous function is only the last one. Why this is a uniformly continuous? Because we can extend this function to the endpoint 0 and 1. 1 is not a problem because substitute x equal to 1, we get a just a well-defined real number. But if you go approaches x equal to 0, we again get some real number. Therefore, this function can extend to the endpoint. Therefore, it's uniformly continuous. All other functions are not uniformly continuous on the interval open to 0, 1. Okay. So, for any doubt, no. Now look at the ninth problem. So look at the function f of x equal to a0 plus a1 times mod x plus a2 x square and a3 mod x cube. It is differentiable at x equal to 0 only when, so what is the, so for what values of a1, a2, a3, the function is differentiable at x equal to 0. So we know that mod x is not differentiable at x equal to 0. The same idea. Suppose f of x is nothing but a0 plus a1 times mod x plus a2 times mod x square plus a3 times mod x cube. Okay. So actually mod x square is same as x square, right? Mod x square is same as, actually this is nothing but mod x modulus of x square. Since x square is positive, therefore modulus of x square is nothing but x square. Okay. Therefore, and then what is modulus of x cube? So modulus of x cube can be written as modulus of x square times modulus of x. So for modulus of x square, we get x square times mod x. Okay. So this function is differentiable at x equal to 0. So why this is differentiable? So we know that when we say a function is differentiable at a, that f of x can be written as f of a plus x minus a into some f1 of x. Find some continuous function f1 such that this is happened, then f is differentiable at a. Now we have to check this function is differentiable at a point 0 or not. Therefore, x square mod x can be written as, so f of 0. So f of 0 actually nothing but 0 plus x minus a, again a is 0, therefore x into this, we can choose f of f1 is nothing but again we can write this is x into mod x into x square. sorry, into x, because x square mod x. Therefore, choose f1 is nothing but x into mod x. So x is a continuous function, mod x is a continuous function. Therefore, the product is a continuous function. Therefore, f1 should be continuous function. Therefore, such a f1 exists. That f1 should be continuous function. This need not be differentiable. Okay. So now this function can be written as is of the form this one. Therefore, this function x square into mod x is a differentiable function at the point x equal to 0. Therefore, no condition needed for a3, because for always x equal to 0, this mod x cube is differentiable, and this is actually reduces to x square. Therefore, there is no condition on a2. Now look at this one. So this, we know that mod x is not differentiable at x equal to 0. Therefore, if it is differentiable, this a1 should be 0. So there is a very important condition. Therefore, a1 should be 0. Look at the last one. Only if a1 equal to 0, then only this function is differentiable at the point x equal to 0. Okay. No problem for no. So if you take a2, a3, anything, it's always differentiable. Why it is always differentiable? This function is always differentiable at x equal to 0. Actually, this is just x square. Therefore, it's always differentiable. Therefore, only problem is this term. Therefore, we can take a1 should be 0. So don't worry with the constant term. Constant term is differentiable always for all the points. Therefore, only if a1 equal to 0, that function is differentiable at x equal to 0. Now, next problem. So the number of limit points of the set 1 by n plus 1 by m, such that mn is an element in natural. So the number of limit points are. Now take a equal to 1 by m plus 1 by n, such that n comma m varies over natural. Both n and m are varying. Okay. Now we are going to show the limit points of this set. Actually, the limit point is nothing but a closure. We are going to show this is singleton 0 union all the n by n 1 by n format. So actually, limit point means what? We have to find a sequence converges to that point. So it contains all the 1 by n format. For example, if you take 1 by 3 in a bar, it's always limit point. That means what? We got to find a sequence in A such that converges to 1 by 3. So what is the sequence here? We take m equal to 3 and then n varies. Therefore, consider 1 by 3 plus 1 by n. Now n is varying. So now this is the sequence in A. This converges as n goes to infinity, this goes to 0, therefore converges to 1 by 3. Therefore 1 by 3 is also limit point. Okay. Therefore now fix 1 by n. Now varying n, therefore this sequence converges to 1 by n. Therefore all the 1 by n's are a limit point of this sequence. Suppose we got to show that and then we got to show that 0 is also a limit point. Now we are varying both m and n. So therefore 1 by m plus 1 by n converges to 0 as n comma m approaches to infinity. Therefore 0 also a limit point and then 1 by n also a limit point for each year. Therefore we have so this is a countable set, right? Because we are n is a natural number. Therefore we have countably many or infinitely many limit points. So look at the first option. We have infinitely many limit points. So what are the limit points? So just in singleton 0 union 1 by n such that n in n. These are all the limit points of this set E. Now next problem. Now look at this problem. Or let A, B, C be distinct real numbers. A not equal to B not equal to C. Then the number of distinct real roots of this equation. Okay. Now this is a third degree polynomial. Anyway, if we expand this, anyway we get x cube. Here we get x cube. Here we get x cube. Therefore 3 times x cube. Anyway, it's an odd degree polynomial. We know that for any odd degree polynomial there is a real root. Anyway, now we got to say exactly 1 real root or 2 real root or 3 real root and so on. Okay, so we have to check this one. Now, what is our function? Better we take f of x equal to x minus a whole square plus x minus b whole square plus x minus c, actually cube, sorry, x minus cube c whole cube. So we got to find the solutions for this equation f of x equal to 0. Okay. Now find the derivative. What is the f dash of x? You have to differentiate by term by term. Therefore 3 times x minus a whole square plus 3 times x minus b whole square plus 3 times x minus c whole square. Now everything is a positive term because x minus a is a whole square, this is positive, a3 is positive, again this term is also positive, everything is positive, therefore strictly greater than 0. Therefore, f dash of x is always greater than or equal to 0. Suppose maybe you can say one term is 0. Suppose this term may be 0, but this term may not be 0. Suppose if it is 0, already we have x minus a equal to 0. That means what? We get x equal to a. Suppose the second term is 0, that is x minus b equal to 0. Again, we get x equal to b. Therefore, we get a equal to b. But we assume that a, b, c are distinct elements. Therefore, at least one term of these 3 terms should be non-zero. Therefore, should be positive. Therefore, derivative is positive. So we know the result. If the derivative of the function, this is a continuous function, right? This f is a continuous function because this is continuous, this is continuous, this is continuous. Therefore, sum is continuous. So f is continuous. So we know that if a continuous function, the derivative is positive. Therefore, this is increasing function. So if derivative is positive, then the function should be increasing. Okay. So therefore, the f is increasing. It's increasing function. Okay, it's not decreasing, it is increasing. But we know that this f has degree 3, therefore it has at least one real. Maybe assume that maybe this is some L. So L is a root of f. Therefore L, the function f passes through this point L because L is a root. Therefore f should be passes through the point L. Maybe because we are assuming increasing, maybe the function look like this one. Okay, because it's positive. Therefore, this function can again is not touch the x-axis. Okay, if it is touches again one more point some yes, then this is not increasing because the function is decreasing now. Okay. Since the function is increasing and it's an odd function, therefore this f has exactly one real root. Suppose if it has 2 real root, maybe as in this one. Therefore, this is a continuous function. Therefore, either the graph look like this one or look like this one. Anyway, both the graph, the function is not increasing, but we know that f is increasing. Therefore, this function f should have exactly one real root. If it is two real root, which is contrary to the increasing function. Okay, therefore, the number of distinct real root is 1. Next question. Now consider the function f is a function from R to R defined by f of x equal to x power 4 if x is rational, and if x is irrational, they defined 2x square minus 1. Now we have to let s be the set of all points where f is continuous. So there is a trick for this type of problem. We have to equal these two functions and then find the values of x. So f is a function from, so this is 12th problem. F is a function from R to R defined by f of x equal to x power 4 if x is rational, 2x square minus 1 if x is irrational. Okay. Now you know that there is a trick to check the function continuity point. Just equal these two functions, that is x power 4 equal to 2x square minus 1. Solve this equation and find the values of x. So we can take x power 4 minus 2x square plus 1 equal to 0. This is nothing but x square minus 1 whole square equal to 0. Right? So therefore, this is x plus 1 into x minus 1. Okay, whole square anyway equal to 0. Therefore, the solutions are x equal to plus or minus 1. So therefore, the values of x are either plus 1 or minus 1. Therefore, this function is continuous only at plus 1 and minus 1. All other points, the function is discontinuous. So this is a trick for this type of functions defined for rational and irrational. Just equal these two functions and then find the values of x. Okay, therefore, the function f is continuous only at those points. Therefore, since s is a set of all points where f is continuous, since f is continuous only the plus 1 and the minus 1, therefore s contains only two elements, plus 1 and the minus 1. So this is the correct answer. So this is a trick. You have to use this trick to find the answer. Now next, let p of x be the polynomial of real variable of degree 5, then limit n goes to infinity p of n by 2 power n what is the limit of this sequence. So anyway, P is a polynomial of degree 5. So better for simplicity, take the polynomial x power 5. Okay. So better for simplicity, take P of x equal to x power 5. Now we have to find the limit of this P of n by 2 power n. So what is the P of n? N power 5 by 2 power n. So better with simplicity called a. So now check an plus 1 by a. It's nothing but n plus 1 power 5 by 2 power n plus 1 into n power 5 in the denominator. Numerator we get 2n. Therefore cancel 2 power n and then cancel 1 n power 5. Therefore if we take n outside, we get n power 5, 1 plus 1 by n power 5, then 2 power n. By 2 power n plus 1 can difference 2 power n into 2 into n power 5. Can cancel n power 5 and then cancel 2 power n. Therefore we get 1 plus 1 by n power 5 by 2. So this is an plus 1 by an. Now we know the one result. What is the result? If limit n goes to infinity, modulus of an plus 1 by an, if the value is less than 1, then an converges to 0. So again, if n goes to infinity, this converges to 1 by 2 because this converges to 0, therefore this converges to 1, therefore the numerator converges to 1. The denominator is constant, therefore this converges to 1 by 2. This value is 1 by less than 1. Therefore, an plus 1 by an value is less than 1. By this result, this converges to 0. Therefore, limit P of n by 2 power n is, the limit is 0. So just use the result. This is very important result. So whenever we have a limit modulus of an plus 1 by an is less than 1, then a should be converges to 0. Okay. Next problem. Now look at this function. F is a function of x to x such that f of x equal to x for all x. Then we have to check f is 1, 1 or on 2. So this is simple. Just use the definition of 1, 1 on 2. We get the answer. Suppose f is a function of x to x, any metric space or any set. So they given that f of x equal to x for all x. So we have to show the first here, we have to show that f is 1, 1. So how to say f is 1, 1? So whenever f of x equal to f of y, we have to show that f equal to y, x equal to y. Now these two are equal. Now apply f both sides. It implies that f of x equal to f of y. That's now apply both sides by f. Now by the hypothesis, f of x is nothing but x, and f of y is nothing but y. Therefore, whenever we f of x equal to f of y, we have x equal to y. Therefore, f is 1. Now we have to check so that f is on 2. So for that, what we have to show, f is a function of x to y. We have to show f is on 2. Given any element y in the codomain, we have to find the element in x in the domain such that this converges to, this maps to y. Okay, so choose, because we know only y, right? Therefore, we have to choose x. Choose x equal to f of y. Now, what is f of x? This is nothing but f of, what is x? F of y. By the definition, f of y is nothing but y. Therefore, you can find x such that f of x equal to y. Therefore, f is a onto function. Therefore, f is both 1, 1 and on 2. All the are false. So this is very simple because a polynomial of odd degree with real coefficient must have at least one real root. Because complex roots are appear in the pair, complex conjugate. Therefore, if it is odd degree, at least one real root. Therefore, simple problem. So last one's the answer. Okay. So far you need to know. Now look at the next one. Okay, which one of the following subset of R with the usual metric is not complete? So we know that complete means what? Every Cauchy sequence converges. Converges to the limit point should be in the set. Look at the third option. It is close to 0 open. Okay, if it is Cauchy sequence here, better take 1 by n plus 1 or 1 by n. Better take 1 by n plus 1. As n goes to infinity, that converges to 0, it is there. But you have to show that it's not complete. Therefore, you have to choose some other Cauchy sequence. Okay. So, if you take xn equal to 1 minus 1 by n, you are subtracting a positive number from the 1, therefore it's always less than 1, right? and then take n in greater than or equal to 2 or 3 anyway. So therefore, this sequence lies between 0 and 1. So and 1 by 1 minus 1 by n converges to 1 because this goes to 0 and 1 converges to 1. Therefore, this is 1, but this does not belong to our set goes to 0 open. Therefore, this set is not complete. Why it is not complete? We take Cauchy sequence, but the limit point is not in the set, therefore it's not complete. And look at the other option, look at the first one. And there is a theorem, there says, yes, complete if and only if compact and totally bounded. So the first set one is compact and is totally bounded. Therefore, this is a complete set. And then this is also, we take any sequence, convergence point is, we take any sequence in the set, everything is of the form 1 by n. The limit of 1 by n is 0. We are 0 also including this set. Therefore, every limit point of this set is in the same set. Therefore, it's always complete. But the question is, which one is not complete? And if you take any sequence here, the convergence point should be in the set. Therefore, this is also complete. So all others are complete except the third one. This is not complete. Just to use the definition of complete, we get answer. Now, look at the 17th problem. So, this is some complex analysis. You got to use the Cauchy integral formula. So, f of x equal to summation n equal to 0 to 15 z power n for mod z belongs to C, complex number. And here, if you take C, the circle is or region is mod z minus equal to 2, and that is the value of this. Now, given that f of z equal to summation n equal to 0 to 15 z power n, and then given that mod z minus I equal to 2, this is our region domain, and the question is what is 1 by 2 pi, just integral over C, integral close to region, f of z by z minus I power 15. Z minus I power 15 dz equal to what? So by Cauchy integral formula, what it says, f n of z naught equal to n factorial by 2 pi I integral over that curve, maybe gamma, f of psi d psi by z minus z naught power n plus 1. If I assume n means the nth derivative, it should be n plus 1. So this is a Cauchy integral formula. So what is z naught? Z naught is nothing but this pole. Here z naught equal to I. Okay, in our case. And then what is our n? N should be, this is 15 given, therefore 14. 14 is our n. Therefore, now the question is, what is this? So therefore, just cross multiply this n factorial by 2n pi. So we have only this. So now apply this one. Therefore, n 14th derivative of f acting at I. This is equal to 14 factorial by 2 pi I integral over that curve f of z dz by z minus I power 15. Now keep this one side because we have to find the value of this one. Okay. Therefore, just cross multiply this term. Therefore, z integral over the curve f of z dz by z minus I power 15 d equal to 2 pi I by 14 factorial times f 14th derivative of I. So since what is f of z is nothing but 1 plus z square plus etc plus z power 15. Okay. If you find the 14th derivative of this function, so we get a 14 factorial plus 15 factorial times z. Okay, just find the derivative, 14th derivative, we get the value this one. Okay, now substitute this value here. So this is equal to 2 pi I by 14 factorial. What is here 14th derivative of, we got to substitute z equal to I. So therefore 14 factorial plus 15 factorial times I. Now 15 factorial can be written as 14 factorial into 15. Therefore, you can take 14 factorial outside. Therefore, 2 pi I. You can take 14 factorial outside. Therefore, we get 1 plus 15 I by 14 factorial. We cancel 14 factorial. Now we get 2 pi I times 1 plus 15 I. So this is the answer. Look at the first one, 2 pi I times 1 plus 15i. So just use the Cauchy integral formula, we get answer. Now next problem. So let f is a function from R to R, this is twice continuously differential function with the f of 0 equal to f of 1 equal to f dash of 0 equal to 0. So all these three values are 0. Then which one is correct? Okay. 18th problem. So we given that f is a function of R to R is continuously differentiable. Okay. And then f of 0 equal to f of 1 equal to f dash of I think 0 is 0. Yeah. Now you have to find the value. So now is the mean value theorem for this interval close to 0, now consider this function. This is function from R to R. Now consider this function, restrict the domain to close to 0, 1 to R. Again, it's a continuous differential function. So here we have a f of 0. What is the value of f of 0? 0. Again, f of 1 is 0. So actually, f of a equal to f of 1. So we know that what is the Rolle's theorem. So Rolle's theorem says, suppose f is a function of closed interval a comma b to R is continuous on closed interval a comma b and differential on open interval a comma b, and f of a equal to f of b, then there exists c in open interval a comma b such that f dash of c equal to 0. So this is a Rolle's theorem. Now instead of a we have 0, instead of b we have 1. So therefore again this f of 0 equal to f of b. Therefore by Rolle's theorem there exists some c in open interval 0, 1 such that f dash of c should be 0. Okay. Now what is c actually lies between? So this is 0 and this is 1. C is strictly lies between 0 and 1. Therefore c is somewhere here. Now consider Rolle's theorem for this interval close to 0, c. Okay. Therefore now consider f dash a function from this to this, because f is a continuously differential function. Therefore f dash exists, again that is continuous. Now we have f dash of 0. It is in the hypothesis given that 0, right? The hypothesis itself is given that f dash of 0 is 0. Now we prove that f dash of c is also 0. Now again by Rolle's theorem for f dash, for f dash, there is some d in open the 0, c such that again if we take derivative f double dash of d should be 0. So since d lies between 0 and 6, of course d is somewhere here. Therefore this d should be in the open interval 0, also, because open interval 0, is the bigger. Therefore this case there exists some d in open interval 0, 1 such that the second derivative of the function is 0 at the point. So look at the second option, f double dash of x equal to 0 for some x in open interval 0, 1. Okay. So by using Rolle's theorem, we get the derivative of the function at some point the function is value 0. So first you use the Rolle's theorem for x, and then once you use this one and then use the Rolle's theorem for f dash, we get f double dash of x equal to 0 for some x. So this is the answer. Now next question. So let A be the closed subset of R, and A is a not empty set, not equal to whole set, then A is not open set, because we know that R is a connected set. You know the only connected, the only closed sets are empty set and whole set, because R, another way of saying a set is connected, you can say the only closed sets are empty set and whole set. If it is closed, it cannot be open. If it is open, then A should be connected. A should be closed, because we already given that closed means what? Both open and closed. It's called a closed set. So already given that closed set, and it cannot be open. If it is open, it should be either empty set or whole set. because we know that in R, the only closed sets are empty set and whole set R. R and empty set are the only closed set in R. Therefore, A cannot be open set. Yes, already given that A is a closed set. So therefore, this is not. Sometimes A be compact set. If you take the closed interval, it's always compact. Okay. If you take integer is a closed set. It's also countable set. Therefore, this is also possible. But the second one is not possible. Okay. Now look at the next problem. Limit n goes to infinity 1 minus 1 by n square whole power n. So just you got to split this value. The problem. So limit n goes to infinity 1 minus 1 by n square power n. So we can, this is nothing but limit n goes to infinity. We can split this 1 minus 1 by even product this n times. 1 minus 1 to n times. So therefore we got to take, we know that limit of xn into yn equal to limit of xn into limit of yn, provided this x and yn converges. This is converges, this converges to 1. Again, this converges to 1. Each term converges to 1, therefore the product converges to 1, therefore directly write the limit is 1. Because use the algebra of limits, and this converges to 1. This converges to 1, therefore the product converges to 1. Therefore the value of this sequence is 1. But it's not E. So actually what is the limit of E? So limit n goes to infinity 1 plus 1 by n power n. So this is the value of E. In general, 1 plus x by n power n, actually this converges to e power x. Okay, here x equal to 1, therefore you get e. So in general, 1 plus x by n power this is nothing but n. So otherwise, saying 1 plus n whole power 1 by. Okay, this also converges to e. So but here it is in the plus and you have some n square. Okay, therefore this converges to 1. It is not converges to E or E or something. Now, 21th problem. Suppose u equal to 2x times 1 minus y. Then the function v of x comma y, so that this function is analytic. So again, we have to check the CR equation. Therefore, we can easily check that if you differentiate this is ux, find ux. Ux is nothing but 2 times 1 minus y. Okay. Therefore, if you find this one, okay. This is y minus 1. If you take minus outside, therefore we get this one. So just to find ux and uy, and then from this option you have to find these are all v. So which one is a suitable v? So first one is a suitable v, such that this is analytic. So just to use the CR, check the CR equation, you get the answer. If you differentiate this is with respect to y, you get with respect to x, you get the same minus of. So this simple thing. So we have to check this one. First one is the answer. Just to check, just to use the CR equation. Now, this question 22 says, suppose we consider some sequence in the open interval minus 1, 1. Then what about the limit point of this sequence? So what do you mean by limit point? There is a difference between limit of the sequence, limit point of the sequence. So when we say a point is a limit point of the sequence, there is a subsequence in the given sequence converges to that point. Then that point is called the limit point of the sequence. So limit of the sequence is nothing but that sequence itself is converges to that point. Okay. So that is a difference between limit point and the limit of the sequence. Now, if you consider any sequence in the open interval minus 1, 1, so what about the limit points of this sequence? So they say every limit point of the sequence always lies in the interval minus 1, 1. This is not true because now consider suitable sequence. This is our interval. Now consider 1 minus 1 by n. So this always lies in this interval, right? Therefore, this is sequence in minus 1, 1. So this sequence converges to 1, but 1 is not in the set. But 1 is a limit point of some sequence in the closed minus 1, 1, but it is not in the set. But the first option said every limit point should be in the set. That is not true because 1 can be limit point, or even minus 1 also can be a limit point of sequence inside this. Therefore, the first one is false. Look at the second one. They say every limit points of the sequence only -1, 0, 1. That is not true. If we take the constant sequence 1 by 2, 1 by 2, 1 by 2, take alpha n equal to 1 by 2 constant sequence. Okay, this converges to 1 by 2. The 1 by 2 also sequence lies in this interval. Therefore, the limit points, they say only -1, 0, 1. That is not true. So they say the limit points cannot be -1 and 1. That is not true, because same example, look at the first, this one, 1 minus 1 by n. So it can be, the limit can be 1 or can this -1 or 0. There can be 1, but the second option can only be. So only that is a false. If you say can be, means it may be true, but they say it's only be, therefore this is not. Therefore the last one is every limit point of the sequence should be in the closed interval -1, 1. That is the correct answer. Thus we can consider sequence converges to that 1, and we can consider sequence converges to -1. So and then it is not converges to any other points outside the interval. It is not a limit point. If you take any point outside the interval, that is not a limit point of the sequence, because we consider the sequence should be in the set. Therefore, all other points are not limit points, only in the interval close to -1. Okay, next problem. Now consider the function f of x comma y equal to x square by y square, and x and y varies from this interval. Anyway, now what is the derivative of directional derivative? Actually, because they give here direction. So directional derivative of the function at the point this along the direction 1, 1 at the point this one. So how to find the direction derivative? Just so write the formula. So suppose f is f of x comma y is a function, and along the direction a equal to a1 I vector, you study in the direction a to j vector. Suppose if you consider x, y, z, a3 k vector. So if you want to find the some L, M, N at the point, so you have to find the fx dot a1, fy dot a2 plus fz dot a3. At the after that you have to find, substitute the x equal to L, M equal to x, y equal to M, z equal to some n. So this is the direction derivative of the function along the direction. Now here they given that f of x equal to x square, here two variables. So f of x comma y equal to x square by y square along the direction 1, 1. That means what? This is I plus j. So therefore a1 is 1, a2 is 1. At the point also 1, 1. So they have justified. So therefore, what is fx? You have to find the derivative or partial derivative with respect to. So actually x square by y square, I think so. Yeah. So what is the direction derivative? Partial derivative 2x by y square. Okay. What is fy? X square is the constant. What is the derivative of y square? It's nothing but minus 2 by y cube. Okay. So this is a fy. Now we have to multiply dot product. Here a1 is 1, a2 is 1. Therefore f1 into 1. Therefore just 2x by y square minus here 2x square by y square. So now at the point 1, now substitute x equal to 1, y equal to 1, we get 2 minus 2. Therefore 0. Therefore 0 is the direction derivative of the function along the direction 1, 1. At the point 1, 1 is 0. Now look at the similar problem. Suppose we consider f of x comma y equal to x into y at the point this in the direction b equal to 1, 2 at the point a1, a2. Then what is the direction derivative? So in the direction is b at the point e. So function is xy. 24th problem. Suppose f of x comma y equal to x into y. So what is fx? We have to derivate partially x. So fy is x. So what is a equal to a1, a2, b equal to 1, 2. So this is the direction. So we have to dot product with the direction. Therefore fx into 1 plus fy into 2. After that you have to substitute the point a1, a2. So therefore this is equal to what is fx y. So y into 1 plus 2 into x. So a1, a2. Now substitute y equal to a2. Therefore, if I get a2 plus 2 times a1. So this is the directional derivative of the given function. So a2 plus 2 times a1. So the correct answer. Okay, now consider the last problem. F of z equal to z by 8 minus z cube, where z equal to x plus iy. What is the residue of a function at z equal to 2? So therefore, z equal to 2 should be a pole of this. Therefore, f of z is equal to be z minus 8 minus z cube. Okay, we can rewrite this. We take minus outside in the denominator. You can take the numerator minus z by z cube minus b. So this is a cube minus b cube. Therefore, we can write minus z by. We know that this is 2 cube. Sorry, z cube minus 2 cube. That is a minus a cube minus b cube format. Therefore, we can write a minus b into. Okay. So 1 minute. So the 25th problem, f of z equal to, you can directly write minus z by z minus 2, a minus b into a square plus 2ab plus b square. So we can write this one, right? Now, the question is, what is the residue of z equal to the function f of z? Okay. So we know that we have to write the formula first. What is how to find the residue of given? Right. Suppose z equal to z naught is a pole of order m. Pole of order suppose m. Then what is the residue of the function f of z at the point z naught is nothing but 1 by m minus 1 factorial into d m minus 1 derivative by d power m minus 1 times z minus z naught power m f of z. Okay, after that you have to take the limit z goes to z naught. Now here pole of order 1 here, therefore m should be 1. Okay, where z naught equal to 2. Therefore, now write the residue of f of z at the point 2 is nothing but limit z goes to 2. 1 by m minus 1. M is 1. 1 minus 1 is 0 factorial. 0 factor is 1. And then this is m minus 1 0th derivative. 0 is derivative, but just no derivative. Therefore, z minus 2 times m is 1 into f of z. What is f of z? Minus z by z minus 2 times z square plus 2z plus 4. Now cancel this z minus 2. Now substitute z equal to 2. Therefore, in the numerator we get minus 2. In the denominator we get 2 square is 4 and 2 into 2 is 4 and then plus 4. Therefore, this is 8 and 12 minus 2 by 12. Therefore, this is minus 1 by 6. Therefore, residue of the function is minus 1 by 6. Therefore, answer is the third one. All of them are false. Okay. Okay. Thank you. Now we stop the class now.